So I thought I'd make a quick little video describing a little gadget I made. Now, the Icom CI-V, and I guess with virtually all modern Icom sets, or perhaps models going back a while, have a CI-V port, which I believe probably is computer interface V for 5, but I've got no evidence of a 4, 3, 2 or 1, but CI-V. Anyway, what I wanted to do was, and I still want to do, and it's a project that's ongoing, is take the information from the tuning from this radio, so this radio becomes a VFO, and control a Yaesu. So I've got this old Yaesu 747, and my intention is that as this radio tunes, that I will tune the VFO on here, and the Yaesu will follow it. So the reason being is that the Yaesu can have a separate antenna, a loop antenna, for instance. So you've got a choice. So interesting thought. Well, CI-V, I can take the data out of CI-V. I need to convert it into Yaesu CAT, different baud rates. So, so the first part of the project was to interpret the CI-V information coming out of this set. So using Arduino, this was the prototype, no longer works. I just tried it, it's broken. But so I made a little Arduino project, and this plugs straight into the CI-V, and it's got a little display on it there, which I'll explain why. One thing I discovered, which I didn't realise, that you don't have to interrogate the Icom. It will output every time there's a change of frequency or mode, or possibly other things as well. It spits out a packet of information. So you don't have to interpret it. You just, whenever you retune, the radio spits out some information. But I thought, great. So I started looking at that and interpreting it. Now what you do is you get a hexadecimal stream, and within that hexadecimal stream is a reverse readable hex digits, which actually are the frequency. But however, being hex digits, you can't actually, you've got to decode them. So for instance, 11 megs would actually decode as decimal 17. So little bit of fun there, trying to decode that into a decimal stream, which I can then re-encode and spit out into the Yaesu. But in the meantime, and there was, you had to break it up, and then leading zeros disappeared and had to be added. But in the meantime, so in this there's a little display here. I had it coming on a display, and I thought, that was a novelty project, and here it is. What if I put the frequency onto a much larger display? So here's the much larger display. So when you first turn it on, it's showing my call zone. Hopefully you can see that. So you will see whenever I change frequency, it is spit out. The radio spits it out, and the Arduino decodes it and puts it onto the display. And I thought, that's quite novelty, that. So originally, because these are 8 by 8, and there's 8 of them, so it's 8 by 64. I originally wrote a bitmap font to use myself, but it was so slow that I ended up using a Arduino library and function to do the display. The only problem with that then was that it's a non-proportional font, so that every time there was a 1, for instance, let's have a 1 here. Every time there was a 1, everything used to jump in, because the 1 was smaller than the other digits. So the only way I could work out how to change that was to I won't say the word hack, because that's not right, but rewrite the library that the function uses. So what I've ended up with is it's quite a mashup, really. But anyway, this is what we've ended up with. So we've got a little unit here, which is say 8 by 64. On the back is a power supply, so 12 volts or whatever you like in, 5 volts out to the Arduino. The Arduino is here, and that is just basically going on a little lead which is on a jack plug which goes into the CI-V port. So the you have to go into the settings of the radio here and disconnect the USB from the CI-V, which I think is the command for it is unlink remote. So now the CI-V port is basically just spitting this out. So I decided to have it just in kilohertz, because generally that's what you're tuning. However, if you decide to go to hundreds of hertz, then we will go into full frequency display. And of course, let's go back there. And if we go to beyond, or 10 megahertz or beyond, I change the display into megahertz. And before that, prior to that, we're in kilohertz. It will follow the memories as well. These are all very strange frequencies. These are for WSPR. But if we scroll back, there's other memories. The other thing it spits out the frequency and it spits out the mode. So if I change mode, the display will display the mode. However, I'm going to take that off. That's a rather useless feature, because what do you do now? You've got to change frequency before you get the frequency again. You can't tell it to display the mode and jump back to the frequency it last displayed, because it may be wrong. So I'll probably take that part of it away. So pretty much there we have it. It's the price of the components is probably about no more than £20 to make. So what use is it? Well, that, as I say, it's a novelty project, so I'm not sure it's of any particular use. But when this screen goes into screensaver, I have my screensaver set to, I don't know what you can, is it 5 minutes or 10 minutes the minimum? This screen will go off. This will remain on. And the other thing I found, which potentially is of use, is if you have this scanning, when it stops scanning, i.e. because the mute's lifted and it's found something, it then spits out the frequency and then it continues scanning. So this will then show you the last frequency that was discovered during a scan. Possible use. Can't say I really do much scanning. So what use is it? Well, I say it's a novelty. It's not much use in the shack, not really. There was a thought that how about if this CI-V port is on a different Yaesu, one that's being used, why did I say Yaesu? Icom, one that's being used mobile, maybe it might be good to have in a vehicle. You could change you could change all of this for something smaller for these. Just have to rewrite the software a little bit, or even bigger. That's a much bigger 8 by 8. So there we are. I just thought I'd make a little video of a rather novelty side project, which is no real strain for the Arduino. This is the Arduino on the back. That's a Arduino Nano, so it's probably the least powerful of all the Arduino, and it's perfectly all right. It can keep up with all the data coming in. Anyway, thanks for watching my little video. Let's turn it off somehow.